All right, last thing, we're gonna look at the determinant of a determinant matrix today. So determinants. So determinant is another command. We write it determinant of A, or like this with the absolute value brackets. Do we say determinant of A? And we see this this is both ways we see. Okay. So if we have a matrix A that's A, B, C, D like that, then the determinant of A is equal to A times D minus B times C. Okay? So, in other words, the diagonals subtracted from each other. Okay? Top diagonal minus bottom diagonal. Okay? So we're going to go ahead and figure out the determinant of this matrix. We're going to do the top diagonal times the lower diagonal up. Okay? So the determinant of A is equal to 2 times 2 is 4. Minus 1 times -3 is -3. So the determinant of A is 7. If I have a matrix like this, then the determinant is just the value. So -5. The reason why we care about determinants is that we can do stuff with them. Okay, so we can test to see if points are collinear. So what does collinear mean? Collinear means that the points are all on the same line. The same linear line. Okay. So here's what the determinant can tell us, is that if the determinant is a non-zero, then the points are not collinear. So if the points are not 0, the points are not on a straight line. Okay. So we're going to look at these 3 points, -2, 1, and 7, 5. And the way we set this up is we put them into a matrix like this. So we're going to call this x1, y1, x2, y2, x3, y3. And then always we make the last, if we're testing for to see if the points are collinear, we make the last column all ones. Okay, so the determinant of A is -2, or our matrix would be -2. I guess this is our matrix. Okay, so -2, -2. Nope. Just kidding. Let's take these away. Okay, -2, -2, 1. We have 1, 1, and 1. 7, 5, and 1. Okay. So I'm going to use a calculator to do this. Love me a calculator. Go to second matrix. That's not what I wanted. Second matrix. We're going to edit a 3 by 3. And this is going to be -2, -2, 1, 1, 1, 1, 7, 5, 1, and quit. Clear all this business. Okay, we want a determinant as an operator, so I'm going to go over to math, hit determinant, second matrix, determinant of A, yes, enter. I get that the determinant of A is equal to -6 So that is a non-zero. So the points are not collinear, or not on the same line. Okay. Go ahead and do the next one, and we will check in just a sec. All right, so I'm going to set this up as B this time. Equal to 0, 1, 2, 2, 4, 3. What do we make this last column? Oh yeah, all ones. Okay, I plugged this into my calculator, and I got the determinant of B is equal to 0. So that is not a non-zero, so therefore the points are collinear. So they are all in the same line. All right, the next thing we can do with determinants is we can find the area of a triangle. So if I have 3 points, thank you, computer, we're almost done. Okay, so if I have 3 points, I can figure out the area of a triangle. So we set it up the same exact way, except for we're going to multiply our determinant by 1/2. If the determinant comes out negative, you multiply by negative 1/2. If the determinant comes out positive, you multiply by positive 1/2. Okay, so here we go. A, the area is equal to the area of the triangle plus or minus 1/2 times the determinant of 0, 1, 2, 2, 4, 3. What do we make this last column? All ones. Okay, so I got that the determinant of A is equal to -3. Okay, so I want to do the area of the triangle is equal to -1/2 times the determinant of A, which is 3, -3. Okay, so the area is equal to 3/2 units squared. All right, last one. What about if I have a quadrilateral? Okay, quick sketch. -1, 2, 3, 4, +2, -4, -1, 6, 1, 2, 2, and -2. So I have a quadrilateral that looks something like that. So a quadrilateral is made up of 2 triangles. I'm going to go ahead and you can cut the triangles wherever you want. I need to do the area of one triangle plus the area of another triangle. So I'm going to start with the area is equal to 1/2 plus or minus 1/2 times -4, 2. So -4, 2, 1, and 6, 1, 1. So to this point, 6, 1. And then I need this other point over here, -4, -1, -4, -1, and 1. So the area of the top triangle plus the area of the bottom triangle. So -4, 1, 1, 6, 1, 1, and then this last point here, which is 2, -2. Right? So 2, -2, 1. Okay. So I get the area is equal to plus or minus 1/2 times -30, which is the determinant of this. Okay. Plus 1/2 times -22, which gives me 15 plus 11. I want to use the negative and then the positive, so we get 26.